Okay, we're assuming that you guys, you know a little bit of beginning algebra. You know how to plot points on the coordinate system. I'm gonna just plot some points, guys. This is called the x-axis, and this is called the y-axis. And I want to ask you a question. Do you think the x values and the y values, or those points, are connected somehow? Are they related? Do they have like some relationship? Anything that you notice about those points? What's going on?
I know they have slope.
So what do you notice here? What's going on? This is the x-axis. These are the x values. You know, any point has an x value and has a y value, any point. And this is the y-axis. This is called the quadrant 1, quadrant 2, quadrant 3, quadrant 4. I put all the points in quadrant 1. That means the x value is a positive and the y value is a positive. But what do you notice? Is there a trend that you observe here with the points? What's going on?
It fluctuates high and low.
What is it?
It's fluctuating to more and less.
Do you notice that as the x values increase,
As x increases,
okay,
y increases.
exactly, that's one observation. Look, guys, as x moves to the right, y goes up. Look, a larger value of x, larger value of y, larger value of x, larger value of y, larger value of x. And here's another important observation to notice. They seem to belong to a trend, you know, to fall on a kind of a line here. They seem like, you know, to follow a line, a pathway, just this way, going that way. Kind of fit on a line. I mean, they don't fit perfectly, but they come very close, you know, just to fit on the line. And this line is called the line of best fit. And when that happens, we say that the points are linearly related, meaning as x increases, y increases. When that happens, the relationship between the x and y is kind of, you know, just called a linear relationship. They kind of fit on a line. I'm going to give you another example here. Take this, guys. This is the x, this is the y, and this is the origin. What's going on here? What do you notice? What's happening as x increases? When x increases, that means it's going to the right. What happens to the y, guys?
It decreases.
It decreases. This is another example of a linear relationship between the x values and the y values. And look, guys, they seem to fit on a line. Look, if I just put this pen right there, it seems like to cover, you know, just all those points. That means they're linearly related. This is called a negative relationship, whereas this one, guys, it's called the positive relationship. Can you give me an example in real life with two variables where they are related this way? As one increases, the other one decreases. Give me an example of two things in life. If one thing, you know, just goes up, the other one goes down. Can you think of something?
I can think of something like economy.
Oh, yeah, definitely. Any example? Give me an example.
It's the supply demand and the.
Oh, when supply goes up, demand
When
goes down. Well, sometimes
goes up, demand goes up too, because it's a positive relationship. But
yeah,
for the
it
demand,
could be both. But I want a concrete example. When x increases, y decreases.
it's the demand curve when like the prices and
Yeah, but that sometimes there is supply, more demand, less supply. It works, just in different ways. Here's an example, guys. If you buy a car, today for, let's say, $25,000. And as years passes, what happens to the value of the car? Do you guys agree with me that it depreciates, it goes down? Actually, guys, the moment you drive your car out of the showroom, if you want to take it back, they might not take it back from you. If they take it back, they might deduct the 20% or 25% of the cost of the car. So that's an example of as years pass, more years it passes, the value of the car will just come down. Can you give me an example, guys, in real life where as X increases, Y increases as well? In a business situation. Let's say the Y is your revenues and X is the number of items you sell. Do you guys agree with me that is the more items you sell, the more money you're going to generate in revenues? Or let's say X is the number of hours you work and Y is the income you generate. The more hours you work, the more income you're going to generate. This is another example of a positive relationship. But let's take this graph right now. Do you guys see a trend here? Do you notice any trend here, a relationship, or you don't think that there is a linear relationship here? Does it seem like I can fit those points on the line? With this one, no, guys, it doesn't seem like there is a linear relationship. A linear relationship, guys, means as X increases, Y increases, or as X increases, Y decreases. But if you notice increase and then decrease and then increase and decrease, then this is not a linear relationship. I'm going to show you some more graphs, just of those linear relationships. And I would like you guys to comment, just help me make a comment whether you think that there is a linear relationship or not. If you look at this one, guys, here, do you think that there is a linear relationship between the salary in millions and the average attendance per home game? Does it seem like as X increases here, guys, Y is going up as well? So then, yes, there is a linear relationship here. Let me show you some more. Look at this one right here. Do you think there is a linear relationship? Definitely. And it's a negative relationship, guys, because as you notice, as X increases, what happens to Y? It decreases. Look, as X moves to the right, Y comes down. Look at this one here. This is called the positive linear relationship, or as X increases, guys, Y increases as well. That's another example of linear relationship. This one, guys, you see the points are scattered all over the place. I cannot tell whether there is a linear relationship. It doesn't seem like there is a linear relationship, so no relationship here. Okay. This one, guys, if you studied intermediate algebra or college algebra, this is not even called linear. This is called non-linear, like a curvy relationship. And we're not interested, just in this type of relationship. Now, when there is a connection between the X values and the Y values through a line, we call that a correlation exists between the two. And as you can see here, he says negative linear correlation, positive linear correlation. Here, no correlation. Or here, it's not linear at all. What we're gonna do, guys, now, I'm gonna have you work with me on this one in chapter 9. I'm gonna show you how we can use technology to plot those points. You learned in beginning algebra. This is what I'm assuming that you know, guys. That's the only thing I'm assuming that you know. If I give you an order pair 3, 4, you know how to plot this on the coordinate system. You just do this, and then you do that, and then you count 3 units to the right and 4 units up, and this is what would be your point right here. This is 3, 4. Another, just show you, like, for example, how to plot -1, 2. -1, 2, guys, you have to go 1 unit to the left and then 2 units up, and that will be -1, 2, and so on and so forth. This is called the origin. This is 0, 0. This is called the quadrant 1. That's the quadrant 2, quadrant 3, quadrant 4. In the business world, guys, we always use mainly quadrant 1 because the X tend to be positive and the Y tend to be positive always. So most of our work, just will be in quadrant 1. What we're gonna do now, I'm gonna have you use your calculator to plot those points. You're not gonna do anything by hand, so I'm gonna show you how to use technology, not just to plot the points by hand. So let's do this together. If you have your calculator handy, guys, I would like you just to do the following. So we're gonna go and put the X values in L1 and the Y values in L2. So edit. I'm gonna clear this list. I'm gonna clear L2 and just put those values. So let's do that. 5.2, 7.3, 6.7, 5.9, 6.1, 8.3. I hope that you're doing the same here, because you're going to be required to do every time you have a question in chapter 9, you're going to need to put the values in L1 and L2. It's about the relationship between X and Y. And I'm going to do 3.3, 5.9, 4.8, 4.5, 4, 7.1, 3.6, 6.1. Okay. Now, guys, we're gonna ask the calculator to plot those points, and what we call this on the calculator is called the scatter plot. Scatter plot means scatter the points on the coordinate system, as you can see it right here, but I'm gonna show you how the calculator can do that for you. And all the instructions and how to do this are already written down here. You guys, you don't have to write anything. So you just press second and Y equals, and you press enter. And we're gonna turn stat plot on. So you make sure that this is on. And actually, guys, it's the first one. You go scroll down to type, it's the first one. You see, when you put a scatter plot, select it says L1 and L2. You need X values and Y values. The X is usually called the independent variable, and Y is called the dependent variable. Okay. And now I'm ready to show you how to do the scatter plot. Now you press zoom and you press number 9. And here's the scatter plot. Do you see that? Do you guys suspect that there is a linear correlation between the X values and the Y values here? Yes or no? Based on just your visual. What do you guys think?
Yes,
Yes. Is it positive or negative?
positive.
Positive. There seems to be a connection between the X and Y values. It seems to be a positive trend, a positive linear correlation. Correlation means that they are related linearly. As the X increases, the Y increases here. There is how strong is this connection? This is a question that we'll answer tomorrow, but there is a connection, just between between the X values and the Y values. And this is how you can see that. You see, you didn't have to do anything by hand. Actually, it's very hard work to do this by hand because it has decimals here. So imagine, look, the calculator did all the work for us. And we could just, by looking at the graph, we could tell whether we think that there is a relationship between the X values and the Y values. X, they call it independent variable. Y is called dependent variable. In statistics, X is called the explanatory variable, and Y is called the response variable. Y depends on X. So X is called the explanatory variable, and Y is called the response variable. Okay. Now, how can we determine how strong the relationship between X and Y is? Here's what we're gonna do. And if you have your calculator handy, guys, I would like you not just to do it now, and you don't have to do it for again unless if you reset your calculator. So I like it just to do this for me. I like it to press the second key, and I press the number 0. You're gonna get this list. And I would like you to scroll down to diagnostic. Again, you don't have to write anything. What I'm saying, it's all listed in this document. You go to diagnostic on. Okay, I'm gonna press enter and enter again. So it's just until you find diagnostic on, press enter twice and you're good. Just do it once and that's it. So again, second, and then number 0, and scroll down. If you don't have your calculator today, you gotta do it later because it's very, very important. Okay, we already have L1 and L2 into the calculator, guys. You can see that's L1 and that's L2. Okay, look what we're gonna do.
Sorry,
now.
can you say it again? You said diagnostic on or off?
On.
On.
Once you get to that one, press enter twice until it says done, done twice. So second, and then number 0. And then scroll down to diagnostic. I don't know how, if there is a shortcut, I don't know how to do it, but I just do this.
And I don't need to do that again.
No, that's it. Once for this chapter and you're all set.
Okay.
It's gonna cause the calculator to display some more information later when we need him. Okay. Now, guys, you're gonna go to stat. You're gonna go to calc. And you're gonna go to number 4. That's the highlight of this chapter here. Linear regression, AX plus B. Have you heard, guys, of the equation Y equals AX plus B or MX plus B, equation of a line? So we're gonna get to number 4 and we're just gonna press enter. And my data is in L1 and L2 if I recall, guys. So I have to change this one to second and then number 1. And then I have 2. I don't touch the frequency list and I'm gonna hit calculate, guys. And all I need before I wrap up today's lesson is this number here, the R. Okay, let me just tell you what R is. R is a number between 0 and 1, or it could be between -1 and 0. So it could be negative up to -1 or positive up to 1. R is a number that can tell us how strong the relationship between the X value and the Y value is. If R is very close to 1 or R is very close to -1, that means the linear relationship between the X and Y is very, very strong. If R is very close to 1, that means it is positive. That means the linear relationship is strong and positive. If R is very close to -1, we say that the linear relationship is very strong but negative. That means as X increases, Y decreases. As you can notice here, R is 0.97, which is very close to 1. That means you can make an assumption, guys, or a conclusion that there seems to be a very strong correlation, positive linear correlation between the X value and the Y value. And R is always between -1 and 1. Just to show you guys something that what we used to do 7-8 years ago, how we taught statistics before. I'm going to show you the formula for R. that we used to make students do in order to find R. Look at that formula. You don't have to use it. It's already programmed into your calculator. This is the formula that students would take about 20, 30 minutes to find the value of R. And look how much work is involved in order actually to come up with the formula. Watch. No need to do this, guys, anymore. All you need just to interpret the value of R. So if R is very close to 1, according to my handout, let me just show you what I put in the handout here about R. If R is very close to 1, we say that there is strong positive linear correlation between X and Y. If R is very close to -1, we say there is strong negative linear correlation between X and Y. If all the points fall on the line, R will be equal to 1. Let me show you the situation when R equal to 1, guys. Usually in real life, it doesn't happen, but this is the situation. Perfect relationship like this. When all the points are on the line, I can easily tell, guys, that R equals to 1. And let me give you an example how R equals to -1. You see, perfect linear relationship, but from the negative side. If R is close to 0, then we say the linear relationship between X and Y is very weak. We will not calculate R by hand. You can use the calculator to find the value of R. Before we wrap this up, guys, I'm going to show you some sketches, and I would like you to try to guess the value of R for me. Just give me a guess, an intelligent guess. What do you think R is in here? So here is some graphs in section 9.1, and I'll be asking you just to make a guess on the value of R. And then we will wrap this up, and tomorrow should be able, just to do the entire chapter in the remaining time. What do you think R is here?
1.
1, very good. Let's check. And you are correct. Perfect relationship. What do you think R is in the second one? It looks positive.
0.5.
0.5. Okay, you're not too optimistic about this relationship. Any other guesses? I mean, it looks like there is a strong relationship there.
0.8 or
Yeah, 0.8, let's see. Oh, close, 0.81, excellent. Okay, this one. Definitely, this is worse than that one, definitely.
0.6.
0.6, any other guesses, guys?
0.3.
0.3, let's see, 0.6 and 0.3. 0.45, right in between. Wow, that's very good. Okay, let's go down now. I'm gonna hide the answers from you guys. Can you guess for this?
-1.
100%, I agree. -1. This one. This one looks like a little bit stronger than that one, but going from the negative side.
Will be negative 0.85.
Negative 0.9.
Negative 0.9. Let's see. Oh, I'm impressed, guys. That's very good. Negative 0.992. Okay. This looks worse than that one.
I would say it's negative 0.3.
Negative 0.3. Any other guesses? It's a little bit hard to determine.
Close to 0.
Close to 0. How close? Make a value.
0.1. Negative 0.1.
Very close, 0.04. And you need technology, guys, to figure out the exact value of R. But actually, guys, if I give you this on a test, And if I give you 3 different numbers, you should be able to match them. You're going to match -1 here. You're going to match the next one closer to -1 with this one, and then you're going to put the last number right there. So it shouldn't be very hard of a task, you know, just do this. Pa, pa, pa. Okay. What do you think the value of R here is going to be, positive or negative?
Negative.
Negative, definitely. It's going to be close to -1, guys. Look, it looks very much close to a line. This one, we don't even use R because R is only used for linear relationship. That's non-linear. That's curvy, guys. They call it parabola. What do you think R is going to be for 11?
No correlation.
Yeah, it'd be close to 0, correct? And guys, here you can see the hint. I put R equals to 1. It is actually 1. And if you ask me to guess this one, guys, I will say probably -0.9897, something like that. Very, very close to -1 because it looks like they all gather around a line right here. We will continue tomorrow, and